Good afternoon, everyone. On behalf of all of us at the National Glass Association, thank you for making time in your day to join us for this month's installment of Thirsty Thursday. Even with the cancellation of this year's in-person BEC conference, the glazing community can still get their education fix with BEC Presents. BEC Presents will spotlight need-to-know topics of interest to installing, manufacturing, and supplier companies in a series of quick-hitting episodes that are about 30 minutes or less. They can be watched on demand at your convenience beginning on Monday. Planned episodes include a state of the industry conversation among market segment leaders, a legal take on the construction industry after COVID-19, including contract and HR implications, a look at the changing commercial real estate market, and an update on what technical codes and standards glazers should know. Episodes drop March 22nd on glass.org. There's no cost to watch and no registration required. Whether you're a binge watcher or you like a paced approach to your viewing your favorite shows, we hope you'll anticipate the episodes to come. NGA has published its first annual report to highlight initiatives over the past 18 months. This report tells the story of how NGA creates value for our members and the industry, illustrating our commitment to a future in which glass is the material of choice. As you read through it, you will learn more about NGA's 4 goals to educate, promote, advocate, and grow, and how they're steering our daily work to help you grow successful companies. We will address questions at the end of the presentation, but feel free to submit them at any time using the Q&A feature in your Zoom toolbar. I'm now pleased to introduce our speaker, Melissa Zotkowski. She submitted 2 photos to depict her garb on a day-to-day basis in recent times, and one to remind you of the smile underneath that mask. Melissa has earned both a bachelor's in civil and environmental engineering and a master's in engineering management. She is a professional engineer with emphasis in structural design. Melissa worked as a design engineer at a Midwest-based architectural engineering firm before accepting a role in glass engineering with Novum Structures. She currently works as the structural glass systems manager for Oldcastle Building Envelope. Melissa was also heavily involved in the task groups that updated both of these manuals we'll be reviewing today. Melissa, welcome.
Thank you, Sarah. Our industry spends a lot of time focused on the exterior of the building and optimizing the energy performance of the facade while trying to maximize the daylighting provided. Today, we will talk about tools within NGA documents that address the use of glass inside the building, the tech tables referenced in the title of this presentation. Both the Engineering Standards Manual and the Heavy Glass Door Design Guide were updated in late 2019, and the recent availability of these documents was highlighted at the NGA annual conference in January of 2020. Who would have known at that conference what the next 12 months would have in store for all of us? For example, who would have thought it would not be strange for me to be wearing a face mask and face shield in the office as shown in this picture? In hindsight, the release of these documents and the tables contained within would be quite timely in the age of COVID. Companies are now rethinking office space use and configurations. Understanding the tech tables in these documents will be important to all who will be involved with the reconfiguration of interior spaces for the post-COVID workplace. This session will be a brief overview of 2 recently updated NGA documents, the Engineering Standards Manual and the Heavy Glass Door Design Guide. The primary focus of this session will be on the updated tables for minimum thickness guidelines for interior walls and heavy glass doors. During this session, I will summarize the document's contents, review some of the more significant changes with respect to interior applications, and describe the historical use of the documents and reasons for the changes. And then we will go on to explore a few examples of common applications. Let's start with the Engineering Standards Manual. Per NGA, the purpose of the Engineering Standards Manual is to clarify the proper selection and use of heat-strengthened and fully tempered glass. This document is a compilation of several previously published sections related to heat-treated glass. The most recent compiled version was published in 2008, though the document sections date back to the 1990s. The 2019 update includes changes to most sections. This document can be purchased from the NGA website. The link is shown at the bottom of this slide. These next 2 pages show the table of contents of the Engineering Standards Manual. Sections of this document address testing standards, allowable bow, dimensional tolerances, standards for silkscreen aesthetic inspection, edge finishes, fabrication prior to heat treatment, laminated glass tolerance, surface compression measurements, and proper procedures for cleaning glass. Today, we will focus primarily on the contents of Section 9. However, it is important to note that this document contains a lot more information than will be discussed today. The second document to be updated in late 2019 was the Heavy Glass Door Design Guide. Per NGA, the purpose of this design guide is to provide authoritative technical information to designers and to offer some suggestions as to the proper application of heavy glass used in doors and entrances. The last publication of this document is from 1999. After nearly 20 years of task group efforts, the document was updated in 2019. As you can see from the 2 side-by-side here, even the artwork got a bit of a facelift. The document can also be purchased from the NGA website. The link is shown at the bottom of the slide. This slide shows the table of contents for the Heavy Glass Door Design Guide. The document includes sections that address types of entrances, types of doors, door hardware, finishes, and general application guidelines for all glass entrance systems. Table 12 from the new Engineering Standards Manual is included as Table 1 in Appendix 1 of the Heavy Glass Door Design Guide. Today, we will be talking about the contents of Section 11 and Appendix 1. So, what were some of the more significant changes to the documents with respect to today's topics, the tech tables? In the Engineering Standards Manual, 2 tables were combined into 1. In this table, joints joined with silicone or permanent clips and open joints are addressed side by side. The deflection criteria for glass linked with clips or silicone and joints is now based on 1.5 inches for glass up to 10 feet tall and 2 inches for taller glass. I have been told the deflection criteria in the previous version was 1 inch. Unlike this version, the deflection criteria was not explicitly defined in that document. Glass linked with clips or silicone and joints was reviewed for both the 5 PSF load from IBC 1607 and the 50 pound per lineal foot at 42 inches above finished floor from IBC 2403. Table 1 of the previous edition was based only on the 5 PSF load. Glass with open joints was reviewed for both 5 PSF load from IBC 1607 and the 50 pound per lineal foot load from IBC 2403. Table 1 of the previous edition was based only on the 50 pound per lineal foot load. In the Heavy Glass Door Design Guide, laminated glass with patch fittings is now allowed in limited conditions per a footnote. This edition is based on the results of collaborative industry testing. Laminated glass with standard PVB, structural PVB, and ionoplast interlayers were tested and have been deemed acceptable for temperatures of 75 degrees Fahrenheit or less. Additionally, hardware limitations for 5-inch glass doors were added to Table 4. The previous table included hardware limitations for 3/8, half, and 3/4 inch glass doors. Why were these changes made? Well, in Section 9 of the Engineering Standards Manual, the committee made changes in order to define applicable code considerations, provide clarification regarding calculations related to the tabulated recommendations, and to reduce the risk of misuse of tables by combining the information into one table. The tables from the previous document were sometimes being misused, particularly with respect to the open joint condition. There was a common misconception that GANA recommendations could be used in lieu of BOCA or IBC codes. GANA always noted Table 1 did not meet 2400 of BOCA, which has been replaced by IBC as the model building code. And the intention always was that Table 2 would be used when considering open joints. The designer or user was never intended to make a choice between GANA recommendations and the building code requirements, because they were actually the same in section 11 of the previous publication. Table 4 of the heavy glass door design guide was updated because there has been an increased demand for laminated glass in interior spaces. Whether for security, acoustic considerations, or other reasons, architects and owners have wanted laminated glass walls and doors. In the past, due to the compressive nature of patch fittings with laminated glass were discouraged or just not offered. After review of the laminated glass and patch fitting test results, the task group members determined laminated glass with patch fittings would be acceptable in temperature-controlled environments. The other significant change to Table 4 was the addition of 5/8 glass doors. The height recommendations provided by the hardware manufacturers for this glass thickness were not simply halfway between the values for 1/2 inch glass and 3/4 inch glass. So the group added 5/8 inch glass to this table. What has not changed in these tables and documents? The intent of the recommendations in the Engineering Standards Manual has not changed. When considering interior glass linked with permanent clips or silicone in joints, silicone still cannot be assumed to reduce the deflection or the stress in any panel. Silicone in joints should not be assumed to add to the structural strength or the rigidity of any panel. The document recommends the panels be clipped together at no more than 4 feet on center to be considered to prevent relative movement between panels. An option does still exist to provide open joints of a width that does not allow fingers to be inserted or trapped. As before, any open joint between 2 adjacent panels, whether between a door and a sidelight or between 2 sidelights, should still be reviewed for IBC 2407, load of 50 pound per lineal foot at 42 inches above the finished floor, using a deflection limit of the thickness of the thinnest panel. The previous Table 1 of the GANA Engineering Standards Manual was never intended to be used for open joints. Table 1 and Table 2 from the previous publication were combined in a side-by-side manner in the new Table 4 in order to present all necessary considerations in one place to ensure that the glass thickness is properly determined. The intent did not change, just the format. The basis of recommendations for hardware configurations in the heavy glass door design guide has not changed. This table is based on hardware manufacturer limits as well as glass deflection considerations. Hardware manufacturers should be contacted for hardware or brand-specific limitations if a design exceeds the limits of these tables. Note that only the hardware manufacturer controls the warranty terms, not an engineer, not a glass fabricator, and no design should exceed the limits set by the manufacturer of the hardware specified. This table is meant to offer recommendations based on the input of several manufacturers, but should not be assumed to cover products of every single hardware manufacturer in the market. So now that you've had the overview of the what and the why, let's take a quick look at these tables and then move on to a few examples of how these tables are commonly used. This slide shows the outline of Table 12 from the Engineering Standards Manual. This table shows the recommended minimum glass thickness for adjacent glass panels with open joints in columns 1 and 3, and for adjacent panels that are linked by clips or silicone in columns 2 and 4. This slide shows the structure of Table 4 from the Heavy Glass Door Design Guide. This table shows limits for hardware for varying glass thicknesses. Table 4 addresses doors with rails or patch fittings, and when either concealed overhead closers or floor closers are appropriate. Now let's move on to a few examples of how these tables are used. This is a P-style door with rails at the top and bottom, with side lights set in rails. In determining the appropriate hardware and glass thickness, both Table 4 of the Heavy Glass Door Design Guide and Table 12 of the Engineering Standards Manual will be used. First, review the door height, door width, and weight of the door for rails and floor closer or concealed overhead closer in Table 4 from the Heavy Glass Door Design Guide to ensure you have an appropriate configuration. Next, review the glass thickness required due to the joint between the door and side light for the full height of the opening. Determine the glass thickness for the door and adjacent side lights by finding the worst case thickness in the first and third columns in Table 12 of the Engineering Standards Manual. If the opening includes a run of side lights beyond the area of the door, and you want to consider using a different glass thickness in that portion, review the joints between adjacent side lights for the height of the opening. First, you need to consider, are these open joints or linked joints? Refer to the first and third columns of Table 12 in the Engineering Standards Manual for open joints. Refer to the second and fourth columns of Table 12 for joints linked with silicone or clamps. Once the glass thickness for the open joint condition between the side light and the door is determined, circle back and review Table 4 for hardware limitations based on the selected glass thickness from the previous steps. If everything still checks out, you are done with this exercise. Otherwise, you will have to review Table 4 for an appropriate door and hardware configuration. In this next example, you see an A-style door with patch fittings top and bottom. This opening has full height side lights, set in top and bottom channels, and a transom over the door. As with the last example, first go to Table 4 from the Heavy Glass Door Design Guide. Review the door height, door width, and door weight for patch fittings and floor closers to ensure the opening is properly configured. Next, review the glass thickness required due to the joint between the door and the side light for the side light height, which is the full height of the opening. Determine the glass thickness for the door and adjacent side lights by finding the worst case thickness in the first and third columns in Table 12 of the Engineering Standards Manual. As with the previous example, if the opening includes a run of side lights beyond the area of the door and you want to consider using a different glass thickness there, review the joints between the adjacent side lights for the height of the opening. Again, refer to the first and third columns of Table 12 in the Engineering Standards Manual if these joints are open. Refer to the second and fourth columns of Table 12 if the joints are linked. Once again, the glass thickness for the open joint condition between the side light and the door, once this thickness is determined, you should go back to Table 4 of the Heavy Glass Door Design Guide and review the hardware limitations based on the selected glass thickness from the previous steps. If everything still checks out and the patch fitting and closer configuration from the original design works for the glass thickness determined above, you're done. Otherwise, you will have to review Table 4 for an appropriate door and hardware configuration. And for the last example, we're looking at the most common and most straightforward of the examples, with a glass wall with top channel and bottom rail. For this example, you just need to know whether these are open joints or linked joints to determine the glass thickness recommended. As per the previous examples, refer to the first and third columns of Table 12 in the Engineering Standards Manual for open joints, and refer to the second and fourth columns of Table 12 if the joints are linked. Today was really about providing a brief overview of the tech tables related to interior heavy glass doors and walls in the updated NGA documents. I highly encourage everyone involved with designing or installing these systems to go to the NGA website and purchase the Engineering Standards Manual and the Heavy Glass Door Design Guide. They contain a lot of useful information beyond just the tables referenced in this session. Note that both documents are copyrighted and cannot be duplicated or distributed without permission of the publishing body. Links to the two documents within the NGA online store are shown here for ease of purchase and reference. Note that current non-member pricing is $70 for the Engineering Standards Manual and $90 for the Heavy Glass Door Design Guide. Member pricing is half that of non-member pricing. At this time, I would like to open this up for any questions.
Great, thank you, Melissa. We have received one question, if you wouldn't mind addressing. It is, when reading the table of two-sided support, top and bottom, does the maximum height reference the actual glass height, overall opening height, or unsupported span height?
For the purposes of these tables, you should be considering the overall height. This is based on simple span beams with the assumption that the glass is set in small channels and the glass can rotate somewhat inside it. So for the purposes of these tables, you should be assuming the overall rough opening height from top of channel at the top to bottom of channel at the bottom. Now, if you want to consider the daylight opening, you would have to contact a structural engineer or a glass engineer who would review the fixity at the top of the bottom channel and the top of the bottom channel and the bottom of the top channel. And at that point, you may be able to use the daylight opening, but these tables are not intended to address different fixities. It is intended to address only pinned conditions.
Great, thank you for explaining that further. To all of our attendees, we hope you found this session beneficial. As Melissa pointed out, both of these manuals are available for sale in the NGA store online, which is at glass.org/store. And they're available both as downloadable PDF or hard copy versions. We also hope to see you again on April 15th for the next presentation in our 2021 Thirsty Thursday series. It will be covering EPDs for glazing products. And Melissa, thank you again for sharing your time and expertise with us this afternoon.
Thank you, Sarah.
Good afternoon.